So here's the rest of the lesson master, 8.2, geometric sequences. A particular car costs $28,000 new. Since it's brand new, this is the starting value. So this would be considered the zero term because it's not the value after a year. It's the value right at the beginning. So we could call it G sub 0. And the car depreciates. That means decreases by 22% each year. So that would be 1 minus 22% or 0.78. Right. So we have the starting amount, G sub 0 is 28,000. And we're taking whatever the previous term is and we're multiplying it by 0.78 because it's not getting multiplied by a number greater than 1. That would mean it was increasing in value. It's getting multiplied by a number less than 1. If I was to write this explicitly, this would be G sub n equals 28,000 times the 0.78 to the nth power. Because this is the zero term, this is n. If it was the first term, it would be n minus 1. So how much will the car be worth in its second year? I'm going to do G sub 2 then. So G sub 2 equals 28,000 times 0.78 to the second power. And I put that in my calculator. So I'm going to let you guys do that. Write a recursive formula for the value of the car in its nth year. I've already kind of written a recursive formula up here. G sub 0 is 28,000. G sub n is the previous term times 0.78. If I felt like for the recursive formula I should start with the first term, then I'd need to find the first term. So I'd have to take the 28,000 and multiply it by the 0.78. And that's the value of the car after the first year. And then I could say G sub n is the previous term times 0.78. So I can write my recursive formula either way. Write an explicit formula. That's the one that I wrote here. G sub n is 28,000 times 0.78 to the n. Not to the n minus 1, because this is the zero term. In what year will the value of the car first drop below 5,000? What I'm going to do is I'm going to put my equation in y equals, and I'm going to go to my table. So y equals 28,000 times 0.78 to the x power, and I go to my table. Okay, year 1, that's year 1, 2, 3, it keeps getting less. Right here in year 7, it drops below 5,000. So year 7, it drops below 5,000. Okay. All right, let's go to number 17. A rubber ball bounces 75% of its previous height. Assume the ball is dropped from a height of 30 meters. So the 30 meters is where the ball starts. It's not the ball after the first bounce. So again, its G sub 0 is 30. And to find the next term, it says I'm going to 75% of my height, so I'm multiplying times 0.75. That is a recursive formula. If I wanted to write it explicitly, it would be g sub n equals 30 times 0.75 to the n. But notice, since this is to the 0, since this is the 0 term, this is to the n. What is the maximum height of the ball as it hits the ground for the first time? So that would be 30. So g sub 1 equals 30 times 0.75 to the first power. And I'm going to put that in my calculator, and I'll let you guys do that yourself. Letter B, write a recursive formula for the maximum height of the ball after its nth bounce. So recursive, that's what I wrote up here. G sub 0 equals 30. G sub n equals g sub n minus 1 times 0.75. That's my recursive formula. Or if I wanted to, I could say what the first term is. That answer that I got right here, I could put right here. And then say g sub n is the previous term times 0.75. Letter C, write an explicit formula. That's the one that I wrote right here. G sub n equals 30 times 0.75 to the n, because this is the 0 term, this is to the nth power. If I want to write it with the first term instead, whatever I got here and here, I can then do that, but then this has to become n minus 1. After which bounce will the ball's maximum height be less than a meter? Again, I'm going to go to y equals and put in my equation. And then I'm going to go to my table. So, y equals 30 times 0.75 to the x. Go to my table. There it is after the first bounce. It's at 22.5. It's getting lower and lower. Right there. On the 12th bounce. 12th bounce. It dropped below 1 meter.